Hello YouTube, this is Morgan, Airspeed Prime here on the next episode of Airspeed's Papercraft tutorials, I guess Papercraft 101. This is going to be episode 2, and obviously as I said at the end of the episode 1 that I'd show these basically pictures of anyone who sent in pictures of things, basically what we made last week, which is obviously this cube with the kind of cube cut out in the corner as to kind of show it. So next you're just going to see kind of pictures of those who sent it in, including Avatar Yang Chen, who is a member of Avatar The Last Airbender Online.com, which is obviously the Avatar fan site that I'm a super moderator on and do lots of stuff on that site for. So she made a really nice version of that in out of brown paper, which is actually something I wanted to like talk about in the first one, but I just didn't get around to. That if you make it out of colored paper, this stuff looks so good. Like for instance, like here's a Papercraft arrow that I made. I have a tutorial up for this anyway on my channel, but look, in blue the airbending arrow looks really cool, as opposed to just it being white and sort of looking like it. So it's cool if you make it out of that, or if you just make it out of like white card and then cover it with colored papers, and all is just as good. But anyway, that's that. That's a good attempt from Avatar Yang Chen at that, and hopefully more will come in as kind of the designs get better and people become more interested in the series. Now, episode 2. Episode 2 is going to be about, in terms of skills, what you're going to learn is, I'm going to do a lot more stuff with a compass. So pretty much everything I did in the first video, I did like just with the protractor measuring it out, the set square. But with this, I'm going to use the compass a bit more to show you a few tricks with this, as opposed to just drawing every single thing out. And in terms of what the design that we're going to be making this pyramid. It's just a simple square-based pyramid made of paper. Now it looks quite simple. You may be wondering like, what's the issue with making this? It's just a square with 4 triangles that fold up, but there's a bit of maths that comes into it with regards to how you like make these accurately and stuff like that. And also it shows you a bit in how to design sloped surfaces as well. Like and I'll get to that when I come behind the camera. But anyway, that's what you're going to be making this week. All you need is one sheet. Again, it's just going to be like about somewhere in the middle, and you'll fold it up. So I'll see you now in a second behind the camera. Okay, so I'm back now behind the camera, and again, this is what we're going to be making, this pyramid out of paper. It's just very simple, made out of one sheet of paper. And with this one, I'm actually going to draw out the kind of isometric projection of this to show basically how I designed it. And then after that, I'll get into, because I'll use what I draw to help demonstrate like how you go about measuring this out and designing it, because it's not as simple as you would think. So what you'll need for this video is obviously a set square. You really just need one of these, really, or the angles don't matter if you had used a 45-degree one or the 60 in this one. I just use this one because it's the longest one, and like you can pretty much do the whole page across, a line across. You will need a protractor. You'll need this. It depends on which way you want to do it. I'll show you 2 different ways. With one way, you'll only have to use this like twice, or maybe even once. The other way, you'll have to use it a few more times. I'd recommend using a compass for this because it makes it so much easier and cuts down on having to use the protractor. So compass, this one obviously opens up and it stays in that position until you move the wheel. Scissors or hobby knife to cut it out as usual. Pencil obviously, and Pritt stick, glue stick, whatever. So that's what you're going to need. Now let's get on with the drawing. Now again, as usual, I'm going to draw out a little bit, show it kind of more clearly to the camera, and then keep going as I do. So this time, as I said, I'm going to show you the isometric projection, how you actually design this out. So you just start off with like a straight line to basically use as your kind of flat kind of axes. Then from there you basically just choose a point, like say here, and then draw a 30-degree angle going either way into that line. and I'll show you that in a moment as I draw it out. So as you can see, just like that, you just draw 30 degrees this way onto the line, 30 degrees that way onto the line, and then also draw a line straight up at this line as well. And there's the kind of basic start, there's your basic axes of how you're going to draw this. Just 30 degrees, and then a straight line up in the middle. Now, the measurements for our pyramid are basically 6 centimeters is the square, 6 by 6. It's 6 centimeters high, and then the measurements for here and here are really depend on like when you draw it out. It's really accurately. So what you do next is basically you're going to draw the square base. So you'd measure 6 across here, 6 across here, 6 up, and then just draw a cube, and I'll show you how to do that. Measure 6. So see, there's the marking for all 6 points, and then what you do is at this line you draw a line straight up, this line you draw a line straight up there, and then you measure up 6 on this line, measure 6 up in this line, and join them there. So, and the best way to do that is to just use your set square and since this is a right angle, just put that level with the line here. Just bring it up to the point, and then you can draw a straight line there. As I'll attempt to show you now. You can sort of see it. You see, there's my little mark here. Put it accurately on the line, and then draw a line straight up. Do the same over on this other one here. And then, as you can see, you have straight up, and then what you do is again measure 6 up from here, so it's moved out here, measure 6 up from here, and then join the point here to that point, and so on. And you see, there's the kind of 2 faces of the cube. And this also kind of explains how I drew the one from last time out as well. And now, what you want to do next is, again, use your kind of baseline here, your basic vertical line here. Now what you're going to do is, from this line, use the 30-degree angle here, and from here kind of draw it up there, and then reverse it and do the same here. I'll just try and show you that. You see, just keep it on this line, bring it across to your point here, and then 30 degrees, because basically the way you're doing it here is that 30 degrees is like a right angle axis, so that'll always be straight across. As you can see, that's all I did. I just kind of went 30 degrees, drew it there, and then just turn it around this way and do the same here. And there is our cube, as you can see. And then what you do is basically there's your square base. Your pyramid is basically going to fit in this. And the way this is 6 high, the pyramid is 6 high. That's the height that you choose. So obviously this is 6 high where it is. We just have to find the center point of this, which is obviously easy. You just draw a line across from here to here, and then where it intersects here is going to be the center point at the top, which will basically be where the tip of the pyramid is. So right there, just by drawing those 2 kind of intersections there's your top point. And then to basically finish off your pyramid, you just join this point to this corner. It's already kind of drawn to this corner, that corner, and then I'll show you the rest of it in a second. So that's all you do, just join that to this corner, join to that one. Well, that's basically your pyramid there. You can see the kind of face of it. It's as if you're looking at the pyramid like that. You can sort of see it there. There's the basic design. It's the same size. And just to show you the basically other side of it, these lines here basically represent what you can't see from this view looking at a cube. So they're behind it, and obviously to make the back face of the cube. So like you're looking at there, the face you can't see is this face here. So that basically just goes back and connects to this point, so you can't really see it. That's what your pyramid looks like in this projection. And from here, you're basically wondering like, okay, the square is easy enough. You can make that in the basic design when you fold it out flat. That's easy. There's no problem making that. But how do you make all four parts like accurate to make them come together so that it comes together perfectly in the center when you're done? And the thing is, like, it's gonna this piece is gonna rotate up along this bit here. So you know this is gonna be laid out flat and then just gonna fold up like that. So the angle like it makes there doesn't really matter. The angle you're actually looking for is the angle here, which on the main design here is actually the angle that's just there, what this angle of this triangle here is. And right now it's actually very hard to figure out what that is, which is where the maths is actually going to come into. Into it and how you actually figure this out. And now, obviously you're going to have to use a few formula, and I'm going to show you that now, how you actually do it. So the aim, what we need to finish this thing is we need the length of this piece. We don't know it right now. We need what the length of one of these bits is and what the angle is there. Once we have those bits, we can make the thing. So how do you do that, you may be wondering. And the basic way to do it is you have to first find out what the diagonal is, what the length of the diagonal is. By halving the diagonal then, you can find out what this is by using Pythagoras' theorem twice. You use it here to find that, and then the second time to do this. You're then going to use the cos rule using this, plus you know that this is 6 centimeters, to find the rest of it. So think of it as like 3 different triangles. The first one is just the bottom of the square on the bottom of the cube. Yep. We know it's 6 by 6, but we're trying to find, we know it's like 6 by 6, but we're trying to find what this distance is by a diagonal. And how do you do that is Pythagoras' theorem. And you have that, that's basically that A, B, and C, there are sides, A, B, C. You just have that A squared plus B squared is equal to C squared. So you can easily figure it out there by just saying it's 6 squared plus 6 squared is equal to C squared, and this is where you're going to need a little bit of a calculator. Obviously 6 squared is equal to 36. You know, it's times 2 since it's the like same thing, 6 squared plus 6 squared. You have 72 is equal to C squared. So you have that right there. And then to find what C is, you just do C is the square root of 72. And what is the square root of 72? You just do 72 to the power of 0.5. And we have that, that's our number. So the diagonal is that much across. It's 8.4885. You don't need to go any further because that's about as accurate as you need it to be. And there you have what C is. So you know the diagonal now. Then what you need, okay, and then like once we have this number here, which is the diagonal on the bottom, we can then concentrate on the next triangle, which is just going to be a right angle triangle that's basically straight up in the middle of this. So the triangle here that we're going to use now is the one that includes this line here. It's going to include half the diagonal, as you can see there, and then the distance straight up, so straight through the middle, and that is a right angle triangle. It's just kind of hard to visualize it here, but this is what it eventually looks like. And obviously the one at the bottom is going to be just half of what you worked out over here, 8.485. The height is obviously just going to be 6 as we chose, and then we just have like half of 4.85. which is 4.26. So you have, that's what it is, and then you use the same thing again. Just the Pythagoras' theorem, this squared plus this squared is equal to this side squared. So the side you're looking for is just going to be equal to the square root of this squared plus that squared. It sounds complicated when you say it like that, but it's really simple. All you do is that by itself, and then square root of it, which I'm going to do right now. Squared plus 6 squared to the power of 0.5. And we get that this side is equal to 7.348. So by working it out, we now have the one that we're looking for. That's the distance we need, 7.348. Next, the final triangle that we work on is just going to be one of the faces of this triangle. So this triangle right here. This is what we're going to draw out on the page to actually make the design. Attach it 4 of these to the side of the square, and we're going to work it out. So obviously the distance here is part of the square base, which is just 6, so we have 6 on the bottom. And then the two sides, this one and this one, are the same distance, and they're just 7.348, 7.348. And as you can see, you have it right there. That's what a triangle looks like. And what we need is just the angle, one of these angles on the side, either this one or this one. And it doesn't matter which one we find, but to do that, because we don't have any angles involved here, it's not a right angle triangle, we're going to use a thing called a cosine rule. And let me just write that out for you right now. And that is that the cosine rule is a squared is equal to b squared plus c squared minus 2bc cos a. So there's your formula right there. A squared is equal to b squared plus c squared minus 2bc cos a. Now that sounds like absolute nothing until you actually look at it in relation to a triangle. So what we're going to do here is I'll just write down here. Here, this triangle. So you call this angle here A, you call this angle here B, this one C. Then the corresponding side is basically A. If you choose A to be here, the angle here, then A's side is this one. B is then side is this one, C is that one. So in this one, what you're looking for is A. So there's your capital A, and then there's the distance A. So you have everything you need. You have B, C, and A. You're eventually going to work out A. In this case, though, what we have here is that A and B are actually the sides A and B are actually the same thing. So what you can do is actually just cancel them out, because basically when you bring it across, it's just going to cancel each other out since it's the same. So all you're left with is basically that when you bring this across, it's like 0 is equal to this. So then it's just that what you're left with is just that. Minus c squared is equal to minus 2bc cos a. Because it's minus on both sides, you can just make it a plus to make it easier. And that's all you're left with. Now from here, all you have to do is basically do c squared, which is just 6 squared. As we see here, c is 6. So it's just 6 squared is just 36, is equal to 2 times 7.348 times 6 times cos a. So that's what we have next. It's 36 is equal to this, cos a. Then cos a is equal to 36 over 2 times 7.348 by 6. Then you have this, because all you do is, since this is basically all multiplication things, you bring everything except what you need, which is cos a. So you just bring this whole thing and divide it across by this. and you're left with this. Cos A is equal to 36 over that. And then to find A, what you do is A is equal to cos minus 1 times 36 over 2. Now, that's all you need to do. So how you actually do that, and you're going to need a calculator for that, how you do second cos minus 1, is first of all just work out what it is. So what we have here is basically that we have 36 over, and just put in brackets 2 times. The answer in this is basically the 7-point thing, the distance we worked out, times 6, and then that's basically the number you're looking at then, which is this, and you have to find cos minus 1 of that. And how you do that on a calculator is you do second function, so that's activated, and then you find cos on the thing, which is here, second function cos equals, and there's your angle. That's the angle that you need, 75.9 basically. And that's all you need. All you need. And there you have everything you need. You have your angle, you have your distance. Really, this is all you need, because when you do this, it'll join up and make the distance you need. So that's all you need, 65.9 degrees. A lot of maths, but it's simple in the end. Now, let's move on to actually making this thing. This is a piece of card. I used paper just there. And how we're going to make it is basically on the sheet, just your square right in the middle, one triangle here, one triangle here, one here, one here. A square with 4 triangles in it, basically. That's what we're going to do. And the key here is just to keep the square right in the middle, so you have enough space on either side to put the triangle. So all you do from there is basically just choose a line, draw a line straight down the middle of the page, kind of as we started off the last one with. Yep, so just choose a line straight down the side of the page, measure 6 across at the top and 6 across at the bottom, and then make your kind of 6 centimeter column. There you go, you have your column of 6 centimeters down the middle of the page. Then what you do is just right in the middle, measure 6 centimeters. Yep, so right in the middle, 6 centimeters. As you can see right there, you have that's a 6 centimeter gap there. And then using the right angle on your set square, go straight across at the top. And then from there you can measure down 6 on the other side and finish off your thing. So you can see right there, all you did was you used your set square to go across, measure 6 down and across. Then what you do is just extend out these 2 lines, extend them out. Basically this is the exact same way we started off the previous one. As you can see, we're just left with that. Then, the big kind of different thing you're going to do is measure distance, like here, measure halfway across. So 3 centimeters here, 3 here, 3, 3. Now put a line straight across there, straight down here. You'll see where this comes in handy in a moment. I'll just do that now. 3, and then we do that line. And then the same on the side. So as you can see, you're then left with this. You have your box, your square right in the middle, but it's also cut in half across and across. Now, what you do first is you draw your very first triangle, which obviously was using the angle 65.9 degrees. This is where your protractor comes in handy. And if you don't know how you use a protractor, you see you have your kind of cross section here. You just line that up with the point here. So we're going to do our angle here. So you just line that cross up, as you can see here, like that. And then from there you just find your angle. So here's 60 degrees and 70 degrees. It says 110 and 120 there, in case you're doing the big angle there, using that. But in this case, all we're using is this angle here, the smaller angle. And then all you do is like count across like 65.9. So you're probably not going to get the 9, so basically just do 66 degrees. Well, actually, it's probably best to do it here. Give yourself some space to do it, because you'll see in a second what happens. So 66. And then look, you should, like, depending on the size of your protractor, basically the angle I used just here, put the protractor there, and the mark is there. So all you do is just join that to that mark, and you'll see in a second what it does. Now, the reason I asked you to like put the line up the center is because right there, you see it crosses this line here. Instead of having to measure again on this side, all you do is just join the point where it intersects here to this, and you finished your first triangle. It helps so much, because using the protractor is probably like the most kind of awkward, I suppose, part of this whole design. And like having stuff like this helps out so much. And the reason I actually do it on all 4 sides is because a trick that we're going to use with the compass. Because rather than having to keep measuring like here and then on the bottom one and then here, instead all you do is look, put your protractor, put the point, the spike, you know, right in the center, which was obviously this kind of where the cross joins up here. You put the spike there, then open it out all the way up to the point where the 2 lines intersect here at the top. So you just open it out a long way up to the top until it there. So I'm just going to show you this closer to the camera. So you can see there that the protractor is open to the like proper distance there. And then what you're going to do is basically, let me see, I'll hold up the camera in my hand here as I do this. So what you do is, like, obviously you have the distance here, and all you do is just go all the way around. And what this does is basically it gives you the mark on every single one of these triangles. So that's the point there, that's the point there where the line intersects. So here, right there, we obviously intersect here, and right there. So, whoops, that's why this comes in so handy, having the compass. And that's pretty much all we need for the compass. From there, all you do is just, obviously you can see here that's where it joins. All you do is just connect the point where it joins there to there, there, and do it on all 4 sides. Connect that to there, and it works out. Then you're left with this. It's pretty cool looking shape there, kind of star, 4-pointed star shape. And that's basically what it is. All 4 triangles are going to kind of fold up. They'll all make the nice point up in the center, which will be 6 centimeters high from this point. And obviously your angles are correct, so these parts will join together nicely. It'll make the really nice design as we have here. The only thing left to do now is tabs, how it's going to glue together. And it's very simple for this in this case. All you're going to be doing is joining this to this when they fold up, this to this, this to this, this to this. So 4 tabs is all you need, just 4 tabs. And the easiest way to do it is to just put 2 on this one and then 2 on this one, and it comes together really easily in when you actually put it together. So in this case, to make the tab, all you do is I'll just draw it out here. So you can see the tab I've drawn out there. You just come out a bit here, don't like come directly out, put it at an angle. I used a ruler to make it really straight here. But the key thing here is leave a little bit before you get to the top. Because otherwise what's going to happen is that if you draw the tab right from the point down, the point actually won't come together at all because the tab will be kind of too big. So you leave it down a bit. Even this is probably maybe a bit too much. I'm going to have to like maybe like cut it about there. But I'll show you when it's coming together. Draw the same tab on this side and then draw 2 on this one. It helps some. Obviously, if you do the 2 here, you have to do the 2 there. Otherwise, you'll have like 2 tabs coming together somewhere. So I'm just going to add the other tabs on. So as you can see, I have my tabs there, 2 there, and then 2 at the top. Then all you have to do is just cut it out. Cut along these tabs. Make sure you get the points nice and kind of pointy so they come together nicely. And that's all you do. And I'll show you in a moment. Okay, then you're kind of really close to the end here. When you're finished, you should have this kind of shape cut out. So, as you can see here, there is a little bit down from the top where the tabs come on both sides, and then the 2 triangles are clear this side. So the first thing to do is fold these tabs in, just in this way, in this way, in this way. Just fold them in neatly to the line. And then just kind of make them so that they kind of just stick up pretty much at a right angle, and that will help kind of when you're putting them together. Next thing to do is just make the folds like here, 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 and here. Just fold the triangles up. And because it's card, it really does kind of just keep its position like when you do that. Just do that on all 4 sides. And then you can see what's going to happen in that, like when you keep the tabs in, it's just going to all come together nicely. Like there it is basically. There it is. And then all you have to do is this. Get your glue. And the first thing to do is just basically finish one side of it. You glue this tab and that tab. And this one here. And then just do it one at a time. Like here, join these 2 bits up very neatly. Make the edge on the outside very nice. Just hold it down. And then do the same on this side here. You just kind of fold the tab in and then really just put your finger in and stick the tabs down on the inside. And there's basically one side of it done. The next thing to do is just put glue on these 2 tabs. Or if it helps, just put a glue along the edge of this triangle on the inside. If it's a bit awkward now that you've kind of put it together. And you can see, yeah, it's glued there. And then just make sure that these tabs are kind of out, and then just put it together here. Just pat it down, just make sure it kind of sticks together. And there it is, that's it, done, right there. That is the pyramid. As you can see, it's completely identical to this one. Put 2 of them together and you get this nice shape. And then in terms of like what you could have done to this, like to make it a bit differently, is like if you didn't want to make it a point, you could have like drawn along here, drawn along here, drawn along here, kind of make a kind of cut off thing, make a kind of rhombus shape, where you have like a square on top, it kind of tapers down. That's another like way you could do the design if you wanted. But there it is. That's it done. You know, from our original design to here, it's come together nicely. So hopefully this video came together nicely and you enjoyed it. Thank you for watching, and bye. Again, please send in basically a picture of your version of this if you made it to the email address, which is airspeedprime@gmail.com. Thanks.